Oh, okay. We're back. I went ahead and calculated that to make sure I was telling you because I didn't want them to do something weird like throw in this 0.285 meters. No, you had to add that to the point. No, because his feet go 0.88 meters up in the air. I'm assuming it's a man. All right, because that's pretty high. Um, 88 divided by 2.54. Yeah, that's a 30. That's about a 35-inch vertical leap, and that's believe it or not, this weird fact. At the NFL Combine, the vertical leap of the players that like wide receivers, linebackers, uh, probably not quarterbacks so much, but some of those players, the NFL actually averages a higher um, vertical leap than the NBA. And the reason is because NFL players are that 3.5 hour game, they're actually only in action for 12 to 14 minutes. Okay. So they're very short bursts of extreme amount of strength, extreme velocity, very fast all the time. So they've got the the muscles for an explosive type thing. Whereas NBA players, it's more of a aerobic type exercise game instead of anaerobic like football. In other words, they're moving all the time, and so they've got a different set of muscles that they've developed over time. That so they don't have as much power in their leap. Some of them can still leap. I mean, there's still 45-inch vertical leap. In fact, one uh, street baller has a 50-inch vertical leap. He's not in the NBA, but he's one of those street baller people. Um, so anyway, that's great. Now, so in part B, the key to part B is that let's look at part B. Let's look at question B. Question B says, calculate his acceleration while he's straightening his legs. He goes from 0 to the velocity that you calculated before. Oh, well, we can do that. You don't have a time. We don't have a time, but we can still calculate the acceleration. We um, we can assume that now this is not a g-force. This is a huge force that he's overcome. In fact, it's going to be about 9 g's probably by the time we get done calculating it. But so we calculate his acceleration as he goes um, from where he goes. I'm sorry, I got ahead reading part 3. Again, we got this is just a repeat of about the same equation. It's just that this time in part B, what we're doing in part B is part B, the initial velocity from part A now becomes the final velocity in the y direction in part B. And that's not bad. Okay, so then you can just repeat the same equation. Except for this time, for my problem, for the problem that I have, for the issues, I got issues. But this time, the height, y final, is equal to 0.285. But it's basically the same equation, meters. And if we wanted to find the time, we could take the average, and in fact, we could take the average speed because we're assuming a constant acceleration, um, and we could find the time. And let's go ahead and do that so then we can do part C, which is calculate the magnitude of the force, which means we have to, so in part C, what you're going to do is you're going to calculate the acceleration, which is, and we can get that from, oh, but we don't know the acceleration here. So yeah, so this is a little bit trickier problem. Don't you wish I'd have worked this out before I started yakking at you? So the acceleration, of course, is v final minus v initial divided by 2, divided by the time. Now, we know the height that he went. What are we trying to find here? Calculate his acceleration. Okay, so we can calculate his acceleration because we got to find the time. All right. Wait. Oh, part B is calculate his acceleration. Oh, what the hell am I doing? Ah, sorry. Oh my. Here we go. In other words, we can still, yeah, I got ahead of myself. So now, so V final is now equal to whatever you got in part A. Okay. So, and then you just take V final Y squared is equal to 0 plus 2A times the 0.285. Okay. And then the acceleration then is equal to V final squared over 2 times the height that he went. All right. Now, and you could have done it. In fact, let me go ahead and calculate that. So we got, in the previous problem, we got 4.153. So I'm going to take that 4.153 and square it, because that's my final height here. Square that, divided by 2 times 0.285. And I get my acceleration is 30.25, which is probably about right. 30.25. So that's about 3 G's. Let's submit that. Let's see if that's right. Yes, of course it is. All right, now I could have also done part B this way. I could have said, real quick, I could have said real simply that V final, that the average velocity times t is equal to 0.285. Well, the average velocity would be that V final y divided by 2 times t is equal to 0.285. So I get 2 times y over V final y is equal to the time. So I get 2 times 0.285 divided by 4.153, 0.137 seconds. Now let's take V final, 4.153 minus 0 divided by 0.137 seconds, and let's see what we get. 30.3. Got the same answer. I got 30.3 this time instead of 30.25, but same thing. Because I found the time and did it. Now, what's the force? That's part C. Force equals ma. Piece of cake. You've got this. All right? Out here.